cybersecurity as a big data problem, getting to know what the Splunk data to everything platform is, how this relates into the cybersecurity space, explore some concrete, let's say, advantages that people gain in using machine learning based approaches, specific detections for threats, for anomalies in general that are happening on top of various security data sets, and also to share a bit more specific machine learning example around DGA detection. This gives you some interesting insights about what can be done, what typically Splunk customers do in better securing and getting their environments more secure, more reliable, more resilient.
Welcome to talk.cybercni.fr.
Bienvenue.
Welcome to Talk CyberCNI, the 21st edition of your cybersecurity speaker series. As you know, with this series, we try to make you aware of cybersecurity risks and of good methodologies to protect yourself. What are the challenges that people that work on cybersecurity face, and so on. As usual, the series is interactive, so you can participate over the Slido with your questions, and Philipp will be more than happy to answer them after the presentation. Even if you don't have immediate questions, it makes a lot of sense that you join the Slido, because in the Slido you can also upvote and download questions. So we already have first questions which say that the sound is there. Thank you very much. So the link is CyberCNI-21, because we have the 21st edition, and you can either scan the QR code that you see here on the left side, or you can go to sli.do and then just enter that key. Okay, that said, what you did not hear, I was briefly talking about this event that will be the next one we are organizing, that is happening in Berlin from the 29th of August until the 2nd of September. During that period on the Wednesday, we'll also have the next edition of Talk CyberCNI. And this event is about IoT and autonomy. We have a very rich program. Check out the website school.future-iot.org. And if you're interested in participating, you can do so physically in Berlin, but you can also participate via Zoom and also via YouTube, Facebook, and LinkedIn stream today. The Zoom stream is paid with a small fee for the reason to assure that you really participate. When you participate there, you have the advantage that you can also present your PhD. If you're currently a PhD student, you can discuss live with the speakers and so on. So I would recommend that. Please share the info about the event with your friends that could be interested, and we're looking forward to welcoming you to this event. Okay, that said, let's just go back, and for explanation, I was switching the PC and therefore recreating all the setups, and obviously I forgot to make some check marks for some sound. I hope that it's not mono, because for me it's showing only on the left ear. So if this is the case, sorry for that. I'll have to check it after today's edition. Yeah, so today, big data, cybersecurity, and machine learning with Splunk. We welcome Philipp Drieger from Splunk in Germany, and let me briefly introduce Philipp. So Philipp works as a principal machine learning architect at Splunk. He accompanies Splunk customers and partners across various industries in digital journeys, helping to achieve advanced analytics use cases in cybersecurity, IT operations, IoT, and business analytics. Before joining Splunk, Philipp worked as a freelance software developer and consultant, focusing on high-performance 3D graphics and visual computing technologies. In research, he has published papers on text mining and semantic network analysis. And this is quite an exciting CV, because it shows that Philipp has quite a bandwidth of interest, which I always find very good. And that said, I hand over to you, Philipp. But before you start talking, just give me a second that I also tick the check boxes for your sound. And if you will encounter sound issues, do not hesitate to write us in the chat, and I will try to solve them as fast as possible. But I think I found which one I have to click. So I just switched.
Okay, so when you can hear me, then I think my audio channel is also well connected. Welcome from my side. Happy to be here, and big thank you, Mark, Oliver, and all the team around you for the invitation. Very excited to be part of this cyber series, and happy to share a few, let's say, insights, lessons learned over the years, and hopefully some inspiration for you. Before we get started, our typical forward-looking statements as a publicly listed traded company, what Splunk is. Any forward-looking statements in this presentation, please only do your investment decisions on real information. Disclaimer to get started. Briefly also to wrap up and share a few data points about my CV. Mark, Oliver already did most of the critical ones, but just also to highlight maybe a few aspects. What I mainly do in my current day job as principal machine learning architect at Splunk, I mostly work with European customers these days, being at Splunk for over 7.5 years, which gave me really the opportunity to get to know various, let's say, complex but also simple challenges that people face in their business, in IT operations, in cybersecurity especially. And one recurring theme, and I will also address this later in the talk, is actually anomaly detection, getting to know when something unusual is happening, and then of course utilize intelligent algorithms, models, techniques based on different let's say mathematical structures as well to retrieve insights from data, or you could simply say get some useful signal from the noise. I'm also trying to contribute back as much as I can to the community. So you find a few freely available apps on Splunk base as well. That's more or less the Splunk App Store, you could say, where you can easily download apps, install them on your Splunk deployment, and have added and enriched features. So that's essentially what I'm trying to do, and let me know how this works for you. Also, of course, giving talks, sharing blog posts, which you can also find from my side. So for today, I want to give you a brief intro what Splunk is for those of you who don't know Splunk yet. Hopefully this gives you a quick first step into. Then I'd like to share perspective as a second bullet point here, cybersecurity as a big data problem still. I'd say when the term of big data arose, actually already over a decade ago or even longer, it was maybe in a different way, but I want to rephrase this in today's still ongoing challenges in the cybersecurity space. Then I go over to give also brief introduction to machine learning techniques, specifically how they are present in the Splunk platform, how you can use and utilize them. And then most importantly, with this knowledge, we will dive into a few concrete examples that we are seeing in the field in real world deployments where Splunk customers utilize, for example, specific machine learning based detection techniques. I will highlight one because this is still I think a very understandable one, DGA detection. I will share a few more insights around this. Also a bit on the data science process, how to walk through such a challenge and how to solve it specifically with the tools and techniques we have. And as a second outlook, or not really outlook, I call it a spotlight, I want to highlight a few, let's say, also lessons learned and practical examples from a customer I closely worked with over the last years, Siemens, based in Munich, Germany, headquartered where I'm living. So we have a good contact with many close customers, but also across Europe. So happy to hear from you. Lastly, wrapping up, giving an outlook, and of course we have plenty of time, I think, left then for Q&A, and I'm happy to hear your questions and to get into discussion with you. So as an intro, who is Splunk? Our mission is really to remove barriers between data and action. Our slogan, you could say, Splunk, turn data into doing, is still what we are living and breathing. And I hope this also gives you some insights later on when you see a bit more in depth what we are doing. Our solution is indeed an extensible data platform that is, I'd say, quite open in terms of how you can extend it. But on the other hand, it also has a few very strengths, industry leading, let's say, technical aspects that really empower you to have a unified security posture across all various heterogeneous data sources that you collect. I will also circulate back on that later on, why all data can be very relevant for cybersecurity operations. And on top of that, of course, with the new streams of observability, full stack, let's say, visibility into what's happening with your systems, with your services, even in hybrid, multi-cloud, different environments, how today's customers typically run applications in or just need to ensure that their IT operations and security are seamless. So Splunk was founded quite a bit of time ago, 2003. We hold a lot of patents. We operate globally across countries, across different verticals also. Still have good growth here with 37% ARR and revenue about 2.5 billion that we typically do. So who are we typically on a business-to-business perspective operating with? You can really see a drop of various logos. You might recognize some well-known organizations here on that slide, really spanning all industries, all verticals essentially. But of course, there are a few sweet spot points, typically in the cybersecurity space and operation space. But even beyond that, there are ways possible to get lines of business addressed, business analytics type of problems to solve with Splunk. And that's, I of it. We are living and breathing data, more or less leaving traces all around us, even while this recording is ongoing. Data is getting generated. We see interaction points. We see different data sources even being generated. But data itself is not longer just a record of what happens. We can also use data to make things happen. And this is, in my best reading, also the way how we can build, for example, predictive models that can tell based on data that has happened what is likely to be happening in future. So I think that's at least my turn how I get the slogan. Turning real-time data really into action. It sounds easy, but in fact it can be pretty hard, especially if you work in hybrid environments, if you have data siloed in different places, if you have legacy systems, on-prem, cloud, multi-cloud, fragmented services that are existing, and of course various point cloud solutions for different purposes. Now, how to get this essentially all together and centralize in one place? This is the very basic idea, still as of the beginning when Splunk was invented, to say with a data to everything platform, we can really centralize, collect all these various types of information in one place to then provide lenses or views or perspectives, you could say, into different areas like typically IT operations to ensure stable operations of your systems, of your services, to secure better what you're doing, to of course also prevent and detect if something is trying to break into your system or doing some unusual activities on your system. Also with regards to development and operations and kind of chaining both worlds into an operational mode, and of course any business related, let's say, applications or deductions. So I'd say from that perspective, quite a lot you can cover. And for most, let's say, more serious customers who have larger Splunk deployments in place, the big benefit is essentially that you can also profit from sharing the data in the Splunk platform for different purposes, for different use cases. So that's the central idea of the data to everything platform. Typically, regardless in operations, in security, in other domains, you can typically iterate on top of your data. This is what this circle depicts here. So as soon as you ingest your data from any structure, any source at any time scale into the Splunk platform, you can quickly investigate. You have more or less a full text, a searchable, let's say, access to your data. This is what we typically call the search bar experience in Splunk. So you could simply look for error, for a specific keyword, for certain patterns of keywords. And by doing this investigation, of course, you can find out unusual, let's say, activities happening, and you can, let's say, take them then into continuous monitoring. This is what we then typically see as a next step when people set up alerts, set up active monitor that looks for specific patterns, and as soon as they arise and occur in the data streams, you can quickly, of course, act even on top of that. So you could shortcut maybe from monitor to act, but most any intermediary things. This can be done on standard dashboards that Splunk is enabling you to do and to build and to customize for your use cases. But also then based on that, you can go into actions and really show what's going on and also connect to automation. So this would be another way of action or to act on top of the data. So in one nutshell, in one slide, if you kind of imagine Splunk as a platform for ingesting all varieties of data from the bottom, you can build essentially into all these, let's say, very integrated, very central component in the Splunk platform. And hopefully this gives you also some inspiration what to do on that side. For cybersecurity, and to frame this as a, call it big data problem, why could we do this? I dropped here two kind of very simple sentences, phrases, you could say, that actually resonated in many, many conversations. Not only myself, but many of my good Splunk colleagues had with customers, with partners. So the one saying is all data is relevant for cybersecurity. You could say, well, that's true anyway, so why do you tell this to me? I do it for one reason. Often we face customers who say, yeah, you know what, we have a specific security tool in place. We have our antivirus system, just to take one example out of many. And that's perfectly sufficient. So we know when some virus activity is ongoing, and that's it. Well, that's what you can do, but the second statement comes then into place. It can be wise to actually collect all potentially available data to you, because in case of a security incident, in case of the situation that you really need to know what's going on or what was going on a specific point in time in your network, in your applications, on your host systems, on your operating systems, then essentially all those security relevant data is interesting to look at. Now you could say, well, I just onboard a new data source as soon as I find it relevant. In many cases, this turns out to be not a good idea, because then likely something has already happened and you effectively face a blind spot that you cannot really investigate. So that's why I think collect data at massive scales in a continuous fashion to really be able to act on top of that data when it really comes down to a specific event or incident that you want to investigate. To make this even a bit more clear, and if we look at a, let's say, example of a cyber attack, as it can typically happen on not only the enterprise zone, this is maybe the part of the diagram here on the left, what is coined level 4 enterprise zone, which would be typically your IT corporate network type of, let's say, systems that you have in place. Your desktop system, some user is interacting with it. It might lead to next steps that actually maybe some malware, some specific pieces are getting, let's say, executed, or the attacker is trying to hide in your network and just wait for another type of command and control activity with the network zones or in your infrastructure. Adding to that, if you imagine you're industrial related customer, you might have an organizational footprint that goes even beyond the enterprise IT level. Then, of course, this can get worse, and your attacker might be able to go into your industrial DMC, into your ICS operations, and potentially really do massive damage at those type of level of operations in the industrial or operational technology side of the world. So in a nutshell, this picture is really here just to explain what could happen and what could be the different pathways, and more importantly, just to re-emphasize that collecting data from all of these layers possibly is definitely more helpful than instead just saying, yeah, it's perfectly sufficient for me to only monitor my activity. That's it, and I don't care about anything else. So I hope this explains a bit. What you can see also on the bottom, if you read 140 days, and there are different reports that you can find in the security industry space, how long it takes really to find out that specific malicious activities were happening. You see, this is quite a long time. And if you can shorten this time, if you can apply more intelligent detection techniques to your ongoing security relevant data that you're monitoring, of course, the better and the more proactive you can be around ensuring your stability, your security, your resilience in general on your operations. Usually, and this is kind of an observation that we have with many customers who go on that journey to improve their security, to be more resilient, it always typically starts in a first stage by being reactive with security logging and investigation. So this means you onboard various logs from these systems. You can look into them. You can search for specific patterns if something was breaking or was having some issue or incident. Then typically you say, okay, based on that gained experience, you can proactively more continuously monitor with specific what we call in Splunk searches or correlation searches that contain, as an example, very simply said, an indicator of compromise that you're looking for. And if exactly this is happening, then you automatically find it and you have an ongoing continuous monitoring. And of course, the ability to act and react on top of that. The next step would then be to preventing things, even automating things and orchestrating things. This is what we are typically referring to as the SOA space, where you could automatically run a playbook that mitigates a specific effect, sandboxing something, unlocking or locking an account automatically, or doing some other automated tasks. And finally, if you kind of bring all these aspects really together and really unify all these security related operations in one place, this is what we kind of call as the security nerve center, SOC, security operation center, that really is able to have all information, all data centrally managed, and of course in a machine speed fashion actable on top of that. Of course, with different people working in such a security operation center, but this would be then also to be defined by people, process, and technology. From a data journey, and this is maybe also a pointer for you if you're interested in building or establishing a bit more completeness on that side, there's the essential guide to security, as you can see here on the left side, a small, call it guideline that we published that you can find on our web pages that are walking and addressing typical stages, as you can see them listed here from bottom up. First off, you of course need to ensure a basic collection of all your security related logs, metrics, machine data from your environment. So this would be really stage one, how most people get started onboarding data into the Splunk platform. Secondly, because there's heterogeneous data sets, there might be different field names, different, let's say, spellings of essentially the same thing, like an IP address, when you want to normalize this into a given standardized name, because this is important to work then across various data streams and sources. So to say, to normalize and apply an let's say, a standardized taxonomy. And of course, if you add to all this machine data your asset and identity data, then of course you have the context and also intelligence to operate sensibly, not only on some machine data IDs, but you can really know, okay, this is a specific host system, it is attached to this team that works with it, and so on. So that's essentially the normalization layer. Then you can further expand by having some additional data sources added, metadata enrichments, anything that you can really build on top. This is kind of the expansion and enrichment phases in stage 3 and 4. And then on top of that, as I explained before, with automation and orchestration, to really have a repeatable, let's say, security operations being maintained and executed as soon as something is happening. And as a last stage, and this is actually what we will now kind of guide over more to the field of machine learning, to say, with the help of machine learning techniques, we can add even more sophisticated detection mechanisms or techniques to be really advanced in terms of the detections of possible security related issues that are occurring. So with that, a quick intro to machine learning at Splunk, what we know and what we do with it. So we as humans, if we reflect, we are quite good at learning, but we easily get lost in volume and detail. I think this is especially true for big data, for large data sets, for streaming data sets that are always changing, that have maybe different characteristics and possibly even change in structure completely over time. We as humans, we can easily learn, try to learn a new language, a new programming language, a new, let's say, foreign language that you want to go because you're going on vacation or something else, then that's a good idea. However, can we translate this into machine world, and how can we teach essentially a machine to have things like that in terms of learning? And this is essentially where the wider field of artificial intelligence comes into place. It has a few, let's say, evolution phases. It quite exists for a long time. It's not something that is just here for a few years. But we could say in general, if you have a function that maps some input features to an output, you could say this is if this is intelligently enough structured, an artificial intelligent solution or system to address a specific need or a specific question. If we narrow this a bit more down and we would say we have a function that learns patterns from data without being explicitly programmed, then we could more narrowly say this is a type of a machine learning type of problem. Models are getting created, they are operating on data and picking up certain patterns with either a given, let's say, output variable, what we know as supervised learning, or if we just run unsupervised learning techniques on a data set like clustering techniques to find patterns. And lastly, if we really go into the space of deep learning as a, again, subset of machine learning in general, you could say, okay, mostly we build neural networks. We build neural networks with deep layer structures that are able really to capture a lot of variation in a data set and automatically, with the help of the well-known back propagation, find the best possible structure for such a network to adapt to a specific outcome. Maybe fun fact, but if you unveil some AI system of your choice, maybe you find out it's just an intelligently nested if-else statement that solves the problem. If so, lucky you. If it's not sufficient, you could say, well, we need more intelligent, more, let's say, sophisticated techniques like deep learning on the right. So in the end, it really depends. But the good news is all of these methodologies are accessible. And most importantly, what machine learning is really not to be thought of, or hopefully you are not acting or behaving like the two guys in the cartoon on the right when you build or design your machine learning system. You should spend a lot of time on really investigating your data, in looking at your data. This is also explaining why data scientists spend a lot of their time in data science projects on cleaning data, munging data, collecting data into a central place. And here you hear a bit also about the advantages when you use Splunk for such purposes. You have exactly many of those type of pre-processing tasks at hand and to operate this on a Splunk platform. It's also not really helpful just to blindly trust data. If you have more or less simply said garbage data that you want to derive some useful predictions from, that's maybe not the best idea. And if you have the impression you're running a SOC and you're just throwing more data at some algorithm, it will not really resolve all your problems. So machine learning still requires you to really understand the problem you want to solve. You should work as scientific as possible, of course, articulate hypotheses, test them accordingly, find techniques that are matching and helping you to solve a specific problem. So this is really simple lessons learned, and my recommendation, if you go building machine learning systems, understand really the fundamental business problem at hand first. Now, if you do, and if you decide to do this with Splunk, you could use, simply said, the core platform search, the language that is available in Splunk, the SPL, the search processing language. This is allowing you to, first off, search all the relevant data that is existing in the Splunk system, like a query type of language you could think of, to then use this to aggregate your data further. You would typically build statistics, you build statistical features that are then meaningful more for a specific machine learning modeling purpose. However, on the other hand, you could also decide to look at one of our packaged premium solutions that we offer for security, enterprise security, for more user behavior or entity behavior analytics, another dedicated solution. So with those solutions, there are machine learning functions already built in. You don't need to be a data scientist to really make them yourselves or configure this all on your own. So this is more ready out of the box functions that you can use. But on the other hand, this is also what we see a lot in our customer base. Some data science professionals, they want to decide and use what specific models they want to operate on. And then, of course, there are helpful tools like the machine learning toolkit, one of the, I'd say, most popular apps downloaded from the Splunk base. And as a companion app and an extension to that, the so-called deep learning toolkit, which is, as the name says, a bit more dedicated for deep learning models, but also for more general data science purposes that you can use this to. So essentially, that's a few components, a few building blocks you can think of. And now, what are customers mostly using this for? First off, again, the prominent topic of anomaly detection. You could say you want to calculate a baseline of the behavior of a specific system, of a service, of possibly an entity that you're actively monitoring. And you do this typically by collecting historic data, by then, of course, doing certain feature processing on top of that, and then retrieving a model that is able to give either a prediction in a specific way. This is how we could switch over here to predictive analytics and use those type of modeling approaches also for anomaly detection. On the other hand, you could also say you build, for example, a forecasting model that tells you next Monday morning we should see this amount of logins or system activity or network activity happening on this device, based on, again, the basic profile that we typically see from the system in the past, and then decide if there is a strong deviation happening, if we see suddenly a huge increase or a specific strong drop in such a KPI, to then compare against this and say, okay, here is something going very different to what we expected that should typically happen. So this is how you can see how anomaly detection and predictive analytics are interchanging with each other, or also making use for the one or the other purpose. Lastly, clustering. Clustering techniques are well known to find structures in data sets, structures of similarities. So we could say for peer group analysis, for, let's say, a grouping of data points that reflect how systems or services are operating, to see, okay, these groups are actually existing in my data. So that's often very interesting for exploring the data as well. But also on the other hand, you could say if you see a new data point coming up, and this is very far away, very distant from any of these known clusters, then of course, again, you could circulate back to anomaly detection. And in fact, many clustering techniques are used in cybersecurity detections, also with regards to that, to not only find structure, but also to find what is not in the structure and have anomalies getting surfaced. Essentially useful also mostly for the classes of behavioral analytics type of tasks, and on the other hand also useful to reduce alert noise. If you always have more or less the same or similar alerts occurring, then you can literally compress them, group them better together, and have them better available, let's say, for investigation. Now, if you also consider that it's not only one guy or lady, a unicorn, who is able to be a domain expert in a specific space, take cyber again, is a Splunk expert and is a data science expert. I rarely came across one such individual. However, you typically compose a team of experts to solve specific machine learning tasks or problems or challenges or use cases on the Splunk platform. So first off, your Splunk expert would be a guy who knows the search processing language, who can build a report, who can build an alert in Splunk, which is quite fairly simple to do with the UI that Splunk offers. But anyways, you should need to have a basic knowledge what to do on that side. Then, of course, your domain experts would really identify the use case, what you want to do. They also understand the business impact. They can hopefully have a clear definition what the success criteria are, and how these decisions are actually then impacting based on the modeling they do. So the domain experts would then interface with the Splunk expert, most likely to identify data that is relevant for the business problem at hand. And then, of course, data science experts come into place and essentially join the project, almost in the first place as well, to be able to identify what is the statistical properties of the data set that is collected, what algorithms might be applicable or a good choice to find specific answers to questions that the domain experts have. And all that is essentially powered by the Splunk platform with the help of the machine learning toolkit as a really central component that each and every of these, let's say, individuals operating and collaborating together are able to use. However, if it goes a bit deeper into the data science side of things, then the DLTK could be helpful, and conversely, the other way around. If you don't have, let's say, maybe too much data science experts at hand, then you could also have the choice for more prepackaged premium solutions type of machine learning that Splunk also offers with regards to a few of our products. So that's in a nutshell what we have here on the machine learning space, how to collaborate, how to interact. A few words about the machine learning toolkit for more technical minded folks on the call today. Essentially, it consists of different experiments and assistant frameworks that help you to have a guided model building experience that is easy also for you to test and deploy those models then for different objectives you have. It is based on standard algorithms out of the Python world for scientific computing. So a set of open source algorithm and libraries that are actually powering the MLTK and that are wrapped then and being useful and integrated into the Splunk search processing language as well, which makes it very tightly integrated for only mostly one reason: to operationalize machine learning models with ease on top of the Splunk platform. And if that's not enough, you could use the API of the MLTK and bring in your own, even proprietary Python-based algorithms, or you could also decide containerized approach and use the deep learning toolkit in case you want to have some specific libraries or GPU computing for your neural networks. So that's essentially what the DLTK stands for. You can also find it as a free app that you can download on Splunk base, likewise as the machine learning toolkit as well, and use this as a bit more an open framework based on containers, containerization, access to Jupyter notebooks, all various frameworks like TensorFlow, PyTorch, or any open source state-of-the-art frameworks you want to use, and of course You could easily customize own containers that you design for your specific machine learning or deep learning use cases, and use this in a very seamlessly integrated and operationalized way with your Splunk platform. So just see it as different tools, different choices of techniques that you can tap into and use. And if we really wrap this up from the perspective of an operationalized data science pipeline, we could say, well, based on the ecosystem apps, the machine learning toolkit, the deep learning toolkit, and Splunk itself as the underlying data platform, we can really draw the chain from data collection, data cleaning, munging, enrichment of data. This is what we call lookups, to really have additional other data merged into the existing machine data. And then, of course, searching the right portions in the data. You can always imagine to have a time selection. So you could say, let's take the last week of data and compare it to this week of data with regards to specific characteristics, which then typically lead into feature processing, feature selection, feature engineering in general, to come up with new features that are useful. Then, of course, to interoperate with algorithms of choice, to build models, to test models, to them over time, to possibly also have a feedback channel to your models that users could give input to your models, how they operate, and use this, of course, then to operationalize it with the desired use case. So it could be a simple alert that you get from your model. Your model could contribute also to a specific dashboard that shows an actual, let's say, status, what's going on, or a process and how it is getting predicted. And lastly, of course, you can share this in terms of dashboards or reports with your team colleagues, with any other stakeholders in your organization or externally who are interested in this. A few lessons learned from machine learning projects in security. First off, a solid data foundation essentially echoes what we had before mentioned in the data science aspect. So the more effort you spend on the quality of your data, of course, the more you can expect and the higher chances are that your machine learning modeling will likely succeed, instead of having not so good, not high quality data foundation, which leads then typically to less successful machine learning modeling. Another aspect is classical, let's say, rule-based approaches are perfectly valid, and they are still, I'd say, useful for all the upcoming foreseeable future. So I would not recommend to replace anything with machine learning, because just machine learning is cool to do maybe. And in between, you also have statistics that you typically generate out of your data set to have something useful that ML can operate on. The feedback loop I mentioned, so for more serious supervised machine learning systems, essentially, you should maintain and curate a high quality feedback loop, either to generate labels or to have a stream of data generated that can tell you something about false positive rates, how your detections are actually operating. So I think this is a big plus if you can add something like this to your machine learning based systems. And lastly, don't also forget about your, call it, risk or business case, so to say. You could imagine to determine the impact of your machine learning based detections on your SOC operations. Are you getting too much false positives with it? I'd say this is maybe not the best choice you do machine learning, then maybe better rely on other techniques. In other cases, how is the business case getting affected? So evaluate your efforts you put into these type of machine learning activities with regards to the outcomes that you can measure. In my opinion, and also what I see mostly often reflected when I talk with security customers, the best of both worlds approach for detections in general will simply apply. So you could have your rule-based detections clearly defined by expert knowledge, clearly understandable in output. The rule matches or it not matches. It has typically a lower compute effort to run this. In Splunk terms, it's simply a search that you do. However, you can perfectly combine this with machine learning-based detections that are retrieving from data a specific model that you define that have, of course, a different nature of output. We speak more about probabilities or how likely a specific output is of a model. Of course, this is different to a rule that simply matches or not matches. So some interpretability is also, taking into consideration to be useful for this. And likely you see a bit of a higher compute amount to train and possibly also to apply these models, which again effectively combines into a best of both worlds approach to see to build the most complex detections you can think of. And with that, let's dive into a few examples. I picked for this talk just really two, essentially it's four, but one main one and a few others just to give a few ideas. The first would be the so-called DGA app for Splunk, which is also freely available on Splunk base. You can find it. You can even find a video description around it as well. So feel free to check it out. This was created many years ago already, but the topic is still relevant for a simple fact that we still see operations that would benefit from a prediction based on the data that is currently happening. For a specific cybersecurity problem, the so-called TAs, domain generating algorithms, that's a technique that various malware and other let's say software components use to generate a random looking domain name. The challenge here is that you cannot really match it with a defined finite number of maybe a threat list or something that really contains all these domains, because it's just unlikely that you can catch all of them, or the other way around, that you want to spend the compute efforts to have arbitrarily lengthy lists to match this. So the hypothesis here, and to frame it into machine learning space more, is are there certain patterns possibly contained in those domain names, how they are getting generated, and can this be exploited to actually have some classifier, literally speaking, trained on top of this data to detect if such a domain name is currently occurring on the network. And if so, then you could have an early warning sign or an indicator of malicious control, command and control type of communication that is currently happening. And of course, with knowledge about your assets, identities, you can further put context to that, and of course locate and prevent possible even more bad things happening. So with that, let me quickly walk you through a few key components that are also contained in this app. First off, it also covers an end-to-end data science process built with the machine learning toolkit with Splunk for this specific challenge or this specific problem statement. As a disclaimer, this is not a perfectly written turnkey solution for every situation and every data problem out there, but likely it could be a good getting started template for you, or if you want to implement a DGA detection, but also with the possibility to retrain these models with your own data, with more data, with larger data sets that you can retrieve, then of course this could be also a good launchpad for you to use. After exploration of the data, we go into feature engineering selection, we create machine learning models, we operationalize those models, and of course, we can test and benchmark them against holdout data sets or different other data sets. So as a data set overview, and by example, you already see a standard Splunk dashboard here appearing. So you can flexibly arrange tables, bar charts, different views into your data. And all of them, this is not visible here on the slide, but we will show in a moment an example of that. This is powered by the SPL, by the search processing language that you can use in Splunk. Now you see here a set of domains. We have around 100,000 domain names, and this is a labeled data set that already contains the classification if a specific DGA is happening. So you can see we have it's only three families of DGA. There are way more, and I will touch that later in the benchmark or in the last part of this exercise. This is the training data set. So we literally have 50-50 positive, negative examples. And within the DGA examples, we have kind of three classes. So this is the data set as it is composed here. Side note, this data set was generated. Luckily, there are published, let's say, code samples available that you can use to synthetically generate as much as DGA data, as far as reverse engineers have found a way to make this available. So feel free to generate your own data sets accordingly. And if we go in the first step with a text mining approach into this data and say, let's analyze with an n-gram analysis the domain names, and with, let's say, a default setting that is available in the MLTK, the 100 dimensions of the most frequently occurring character groups of 2 to 3 characters. And we are compressing this then later on with a principal component analysis into a 3D space. We can look at this, and if we color this accordingly, blue as legitimate domains and yellow as DGA-based domains, then we can see how this spreads in the space accordingly. On the right side of this diagram, you can see even the subclasses being colored. So again, blue would be the legitimate domains, all the other ones, and you can clearly see they are residing in specific spaces here, which is then, I'd say, a first good insight to actually apply a classifier, because they are nicely separatable in space. So I think this is a good precondition. A bit of SPL code here for you, maybe just also as an alternative that you might want to consider. So it's fairly simple in the SPL to define your data processing step by step. You can see that the TF-IDF runs on a sampled set of the domain names with the n-gram analyzer. We can memorize those model already into the DGA n-gram model. Later on, the PCA is happening. Again, we memorize this into a model. And then lastly, just a bit of formatting and plotting. And here we go. We have a nice plot of this data in a 3D fashion. You can turn it around, you can investigate, and so on. From a different perspective, let's say we use this and add even more features, and by far this is not extensive, so feel free to even add more feature engineering ideas on top. A few of them are listed on the bottom of the slide, but you could also consider simple things like the length of the name, different Shannon entropy measurements, the meaning ratio, how likely known words in a dictionary are substrings, essentially, the domain name. And with all these added and additional features, plus, of course, the PC123 on the right side, the principal components from before, we could now have a data set that is actually useful for further machine learning. But before we do that, let's share also a few more, call it investigations. If you just plot in such a scatter plot type of diagram, the legitimate domains and the subclasses, we can clearly see or estimate even a boundary level where it is quite easy to separate the space from known DGAs and legitimate ones. On the other hand, the principal components, the meaning ratio, some of the other features are also getting listed accordingly here, and we can identify which ones are maybe more carrying, more useful, more predictive, you could say, with regards to our goal. And lastly, if you just want to get everything in one picture, a parallel coordinate chart could help to literally retrieve over a multidimensional representation of this data set, how the characteristics are, where are specific, let's say, parts. And if we just highlight the DGA ones, you can maybe see in this swapping that specific patterns are there more for legitimate ones, and conversely for DGAs there are others. So this might be the next good idea, to then go into actually building supervised learning models on top of that. We choose to just pick 4 standard methodologies, but feel free to add even more with even newer techniques, including neural networks or specific LSTM-based approaches that look at the character sequences of a DGA or not DGA. So there are various more ways. But for the first step, let's just compare the rates, you see the confusion matrix of each of these model runs, and then you can, of course, aggregate and combine across and see that, for example, the random forest here was the best performing algorithm on top of this data set. So this is the one that you then possibly choose to operationalize and say, okay, on my ongoing data, I can apply this model, the selected random forest model. And this is really also, it's static here on the screen, but you can imagine new data arrives and you get an instant classification of potential DGAs happening in your data stream. And with that, of course, you also have the ability to memorize the findings and have a feedback channel essentially for an analyst to say, okay, this specific finding was a DGA, was legitimate. So to give additional labels into the system, which can then, in the next step, of course, be reused for improving the model, for having additional features incorporated into the model. So I think this gives a good way forward. If we wrap this mechanism up in a simple diagram, we could say incoming unknown domains get classified by the existing model, by the apply statement. We see the DGA classified domains. They are populating a so-called KV store in Splunk. And then out of that KV store, we can either use or reuse things directly for allow and deny lists, or the other way around, we can add additional, let's say, input from the analyst to the next model training run, which is happening in a scheduled way, which again creates a new model that has incorporated the new information. So you can see the diagram how this mechanism would flow and would be operational then accordingly. Lastly, a quick view on testing and benchmarking this. So remember, we trained a model essentially on the lower three, Locky V3, Keynote, and NuGOS type of, let's say, DGAs. Of course, they are getting recognized pretty well because the model has learned them, has learned the characteristics. However, and this is now the interesting part, if we run this very small trained model against a way larger and bigger data set, which contains over 1.7 million of domains with up to 10 more different subclasses, then we can easily see that we still get good recognition rates, let's say for at least a few more here from the list arising. Of course, on the upper end of the list, we don't really recognize everything because these are completely different structures, different ways how these DGAs, let's say, articulate their domain names. However, we can also use this data set that was used here for benchmarking to actually use this for training. And then obviously you can imagine that this gives then the desired detection across that. But I think the main point here to really note is that machine learning based detections can also help to find things that you not yet really know about. So the so-called unknown unknowns, we have heard about this in a few ways to say, okay, we can even recognize what's going on there. So that's one example. Another example that I want to quickly share, and this is also a pointer forward to existing conference talks that are existing. I will also share a few links later on. I was very lucky to collaborate with a few good folks at Siemens who run the so-called Eagle data center. This is a high secure and highly protected data center. Obviously, they operate with Splunk for many, many years to have a continuous security monitoring in place, of course, across all various data sets and data streams that are happening and occurring in this data center, as you can imagine. So a quite huge variety. Simply put, back to a big data set, you could say, that is really retrieved here. And the challenge, of course, is to continuously improve more detections, have new security threats under control that are possibly arising. And the idea here was as well to also investigate how machine learning based approaches can help and can provide, let's say, different insights, additional detections that are useful for their security operations. In short, the result when they implemented some of them they saw an improvement in their detections with additional insights into their system behavior. So it was quite helpful for them not only to have new detections, but also to learn and to better understand what's going on with the help of such techniques. And finally, also as a conclusion that resonates with what I said before, data quality and the workflow integration was really key to success for them to operationalize those machine learning approaches. To share a few of their attempts and actually successfully implemented ones. The first, which I will also detail a bit more later, is essentially anomaly detection for deviation of past behavior in terms of servers that are specifically, of course, having outbound communication into public internet. The proxy communication essentially is a data source that is then be useful to determine if something is going different on such a system. And of course, this is noteworthy and good to know for the operations, but also for the security of these systems. Secondly, predictive analytics type of techniques. We looked at a classification of directly, let's say, command line level executions happening on operating systems to directly identify possible system compromises in case of a specific given sequence of malicious commands in a living off the land style, when in the case an attacker would make it, let's say, to an operating system level, if they would execute specific commands in a chain, then we build a model to directly predict if such a situation is happening based on the selected features. And this was pretty helpful for them to automate better, to have, let's say, a detection running at scale on top of the daily 20 million command lines that are happening. So the clustering, lastly, were techniques they explored for mainly protecting privileged accounts. This goes a bit more into behavioral analytics type of approaches to essentially find unusual activities. You could think of account compromises if they happen, and if they happen on a very, let's say, high profile user, then of course the risk or the possible damage is the greatest. So this is what they specialized on, to really have a very specific protection for some of the, let's say, most sensitive accounts. So these are three examples, and I hope this is also underpinning or inspiring you a bit what machine learning techniques can do or can extend even on top of the classical, let's say, rule-based approaches. And to go even a bit more further into detail around this anomaly detection technique that was used in the first case here, to profile system communication for outbound traffic and detect changes in behavior. So essentially the data sources were web logs, web proxy logs. We decided to do certain feature engineering, of course, to aggregate data that is ongoingly computed in the system into specifically sliced 1 hour slices that describe specific behavior, like how many distinct net locations a system was accessing, which user agents were active, which categories have been attested there, how many bytes in, bytes out traffic was happening. So just various characteristics that describe what's going on with the system. And then for each of these characteristics, we decided to train a so-called probability density function model. And we do this not only at once over all the systems, which would be a bit of a too global scale, but we decided to do this, let's say, on a per system basis. So you can think of a profiling of each and every system's individual behavior over time. And then later on, of course, we can easily apply all these models. And as a final step, we aggregate the results. So you can think of a first layer of anomaly detection. And then as a second pass, you further aggregate over all the outliers, find again specific groups or more frequently happening things on a system, which is then essentially very easy to display in a very simple bar chart, as you can see here on the bottom left, that simply highlights which IPs, which systems are having the most anomalous activities. And for the turquoise colored one, this is essentially also the system that was, let's say, used for testing and for verifying, for example, with HTTP tunneling of SSH traffic, something that should not typically happen on such a system, but for it was good to validate it that way. From this first insights, then an analyst could jump deeper. They could drill down into a different panel, into a different view of a dashboard to see even more specific metrics or even down to the raw log information, what's going on the system for investigation. So as a conclusion and to wrap up, let's say a bit what was achieved here and what was also beneficial to do. New monitoring capabilities came into place. I mentioned the 20 million command lines being classified every day by machine speed. So of course, it's unreasonable that any human user would look at this amount of command lines daily. Pattern analytics are in place, so it's not only, let's say, looking at when is a certain threshold beyond a given limit. It's more looking at patterns, at structures that are interesting to surface. And from an efficiency standpoint, of course, this also allows smoother day-to-day operations and actually more time for use case development if you utilize those techniques that have a good potential for automation. And lastly, it expands, of course, all the existing security monitoring tools and rules that are in place and have also ways to tune, let's say, those type of detections accordingly to the, call it, appetite of how much, let's say, output of such a model you want to see. So that's essentially the benefits here. And then to finally, but also come to an end of the presentation as a quick wrap up and outlook, I would like to point you to past and upcoming conferences. The upcoming conference, a good colleague, or actually colleagues of mine, Josh Cowling and Marcus LaFerreira, are giving a talk at the Cyber Threat SANS conference happening in London in September later this year, where we explore specific data science techniques for analyzing TLS signatures, which could be of good potential for future detection techniques. So that's a pretty exciting topic or project colleagues are working on here. Secondly, the last Splunk Worldwide User Conference, which is happening every year and of course happening next year as well. That's why it is a past but also an upcoming conference, which I can also recommend you looking at the online archive of all the other customer talks that you can find there. So it's really a huge universe of hopefully inspiring industry talks that other customers were doing and achieving and having success with the Splunk platform. More security content related, I want to quickly share two highlights that you might also want to check out. First off, our research.splunk.com, Splunk's security threat research team that is publishing various content, and you can also go into this. There's a GitHub repository that you can check out, but there are also pre-built, let's say, security content update packages that Splunk customers obviously can use straight out of the box to have even more detections up and running. And of course, also to point at a special team at Splunk Search, so to say, your trusted advisor for a timely security research and guidance perspective. Lastly, things like SolarWinds, Log4Shell, all these type of activities where you want to get immediate, let's say, next steps. This is what this team is mainly focusing on. So I hope this gives you some interesting insights maybe and things you want to check out. And lastly, of course, if you also want to take advantage of Splunk's data to everything platform, you can download today. You can start with a trial even on a local laptop machine and get your hands dirty with it and try things out. Or you simply start with us in the cloud. That's all the choices you have. And especially because we are now here in the field of academic research as well. So if you want to apply as an academic institution for Splunk, then there's also ways how you can get free licenses and some, let's say, training type of learning experiences that hopefully can also help maybe some of the research you're doing, or we are also happy to collaborate with any interested research universities that are interested in utilizing Splunk. So with that, I hope this was good information for you and a few things that you can hopefully use and pick up. And with that, any Q&A for the remaining time. Yeah?
Great, fantastic talk. So I really loved it, and all the structure that you put in, the insights you shared, and the audience obviously also loved it because we have more than 30 questions that are awaiting us. And Alex, as usual, has the challenge of moderating this. And also, as it is our tradition, I also have some additional questions to those that are in the chat or in the Slack in the Slido, and the first one is also related to your wrap up. So you said Splunk was founded in 2003, and back then my dear friend Florian was also joining, and who also created the contact to you. And I were working on a lab course on different aspects of computer networks. And back then we also worked with a tool that was or is called Snort. So it was a rule-based intrusion detection tool. And when you look back now from 2003, which would be the biggest evolutionary steps in the tooling that you would want to highlight, like just 5 or something like that? I mean, it's a very general and big question, but if you personally would look at it, so which were the milestones in the tooling towards where Splunk is today from the first basic rule-based tools that were on the market?
Good question. Let me address it in that way. So first off, I would say the really the core technology at Splunk, the time series based index, the ability to quickly search for specific patterns. I think this is still very true, and of course it evolved over time, so it got optimized. There were various performance improvements. However, the core functionality is still, I'd say, the same as in the beginning. Of course, some specific aspects, some details came on top. Machine learning approaches were one of them. So this was something that was not present in 2003, I think, or at least in a very minimal way. So we can see over, especially the last 5 years, that there is more need, not only from our customers, but even from our internal teams who say, okay, we want to imply specific new detection techniques. And this leads me now a bit more into call it the ecosystem or the content space. So I think based on the flexibility of the Splunk platform, if you just imagine how many different apps are existing in the Splunk ecosystem. So there are 2,400 listed. Obviously in 2003, there were not as many. And this is also what I think points us to the collaboration that Splunk has within the wider security ecosystem. Whatever, take all various vendors, cloud providers, take any infrastructure component, even on the industrial side, have many partnerships, technology partnerships. So I think the big evolution, apart from, of course, technical improvements and new features that we build into the product itself, I think is also going hand in hand in a collaborative way with our customers, with our partners, with our technology partners, and have just a more complete, more full pictures. And apart from that, of course, there are a few known, let's say, acquisitions that Splunk did over the past years. And of course, this also extends our product portfolio. But I'd say this is the evolution, at least I personally, how I'm observing it. And I think this has good potential, yeah, for the future to have even more content built, to stay, so to say, head to head with upcoming new security threats that are arising. And I think the critical ingredient, at least what I learned, is if you have the flexibility, if you can quickly and easily adapt and change maybe your way how you do detections, how you write specific detections, then of course you can more easily switch, let's say, to new detection techniques instead of having things more or less pre-canned, completely black boxed, where you as a, so to say, customer or user of Splunk has not so much control about it. So I think this is the big flexibility point or still openness point also from the platform. But that's just my personal observation, how I'm seeing the evolution of Splunk in this regards. Hopefully this shares a good perspective, but yeah, let me know.
And very, very good and very interesting also, because this collaborative social working together on it aspect is something that we see in many different computer applications. And so it's very good to see that also in the cybersecurity, this is a key thing that is happening, because I personally always think that it's a very good thing to have many forces and join them to build something. Great.
Yeah.
So Alex, I know we have tons of questions, so I
Yeah.
hand over to you for the moment.
I will try to filter them, maybe to regroup them in topics. So first questions will be about the Splunk company. So who are the Splunk customers, rather big or small companies?
Good one. Yeah, this is one of the slides that I presented in the beginning. This one with many logos on the screen. For sure, fully true what actually the question is intending to look at. So we really have small companies, you could say startups, digital native type of, really small teams that see a lot of benefit and value in using and utilizing the Splunk platform. But of course, on the other hand, also historically, we have a strong footprint in the financial services space. Of course, you can read things like NASDAQ, for example, to have stable operations, such type of business, and even in healthcare, in different government agency spaces, public sector in general. In the technology space, telecommunications is also a strong way. And of course, if you include, let's say, any manufacturing, industrial related ones, you can easily see it's really from small to really completely large scale operating big business type of companies. So it's a good mix, I think, but sure, it's not only intended to work with big or small customers. So it's for me not a neither nor question. It's more like an and question. So useful for definitely all these type of profiles of
Okay,
organizations.
thank you. So another small question, I think you've answered it a bit, but is your solution offering the full stack from monitoring over data analytics to countermeasures? So I think the question is mainly about, do you provide in Splunk some actions to counter if we can see an attack, or is it for only for monitoring?
Mhm, mhm. So essentially, we have a framework called Adaptive Response Framework, and we have the second choice, what I also mentioned, the SOA automation piece. So this could connect you to direct, let's say, actions, counter actions, not directly. So I'd say Splunk is more on the, call it detection, security incident event management side of things. It's, to my best knowledge, not the tool of choice to do active, whatever, countermeasures. So I think there are other tools in the security space available. But I think also here with open interfaces, you could connect any other third-party systems accordingly with the interfaces with Splunk. So not something that we primarily intend to do as a product, but our customers are also, what I experience on a daily basis, very creative, very technically profound to really also connect Splunk to various other tools and techniques that they want to use and have in place. So hope this explains or gives a good answer to that question.
Okay. Thank you. To continue with that with this question, you've gave information about we can just begin to work on Splunk right now. But the question is, if my company does not use Splunk yet, what would be the first steps to get to know it?
Mhm. So the first steps to get to know Splunk essentially as a
Yeah, I think if we want to begin to work with, what should
Mhm.
we do, or what can we do to facilitate this transition?
Yeah. So I'd say first off, of course, check out Splunk's official website, splunk.com. You find either plenty of resources from direct links, so to say, to download Splunk Enterprise as an on-prem available software that you can easily run in a trial mode to experience the functionality, to see how things are working. I would heavily recommend pairing this with some educational, let's say, exercise. We have plenty of videos, e-learning type of courses that are also free to consume. So just to give some guidance in the first step to get started with. But so if it goes, let's say, a bit more serious and productive, feel free also to reach out, obviously, to Splunk. We have dedicated account teams for different customer segments. So people like myself or like many of my colleagues who are working with me would then also be happy to guide you and help you in specific projects or if you need some guidance. Plus, not to forget our very widespread partner landscape. So Splunk is operating with many industry partners. So you can think of from global system integrators down to local specialized partners who can also help in getting Splunk up and running in a specific place, helping a specific business or organization in getting to know Splunk, getting to know how to work with it, how to configure it, how to run it, and of course to reach a specific goal. So hope this gives some aspects here.
Okay, and to finish, I think the part with the Splunk company itself, the COVID question. Which effect did COVID have on your business? Did you gain a lot of customers, or are people more or less aware of cybersecurity?
So I don't have, let's say, precise numbers or anything that I can easily share here. I'd say in general, COVID has an impact on many things, especially also in the digital domain. In the cyberspace, I'd say what we, and especially also related to our customers, what we are seeing, many people are on remote work. That's also not a secret. And therefore, there might be additional attack vectors that should be encountered if you want to, of course, better protect your workforce, your operations, how you as a company operate, and how your employees, how your, let's say, people are still securely interfacing their systems and doing their day job with any IT equipment. So I'd say definitely there is an impact. That's for sure. But how it specifically plays on Splunk business, I'm not in the position to have good enough information to share at this point. But from a wider perspective, definitely remote work related. Let's say better protection that is then sought and needed, I think is what's definitely known and yeah, publicly available known as well. Yeah.
Okay. So no, there is okay, just okay. There were lots of questions or more questions about AI or machine learning. But first of it, two questions were about your data sets you can use, and if you can share or do you have some data sets that can be, I don't know, shared with researchers or people that want to try it for free, maybe to see if your model are fitting their expectations?
Sure. That's a very good pointer. And in this case, sharing is caring for sure. So first off, the example of the mentioned DGA app, the app itself contains, let's say, at least the data sets that have been used for this app and for also the models that were created with the help of this app. So this would be one source. We have a few other additional sources. I mentioned GitHub, which is maintained by our security threat research teams. This would be another place where you can also find data sets. We have what is maybe also very interesting for you to look at, a so-called workshop or challenge session called Boss of the SOC, which allows you as a blue teamer to get hands dirty on an, call it simulated but very realistic data set. This is called the bots data set, which could be also interesting from an open source perspective for security researchers or people to look at. So this is available on our GitHub and Splunk sites. Just maybe navigate for those type of keywords, then you should be finding them. And apart from that, I'd say any other, let's say, data sets that are okay to publish. Of course, you also know privacy, anonymization concerns. Splunk has for sure no customer data at this point, of course, because customers use Splunk in their environment with their data. So in rare cases, there's maybe some collaborative work on that, but it's not, let's say, the standard that every customer is easily sharing data, especially if it comes down to more sensitive data, which is fully understandable. And also, of course, what I hear essentially also in the wider security research community, not always the best condition, to build a machine learning model if you don't have, let's say, any realistic data set at hand. So I think this is one big ongoing challenge still, and definitely a good point. The more we can share with each other, the better we can all get together and build more useful models. So at least we do also some sharing in this space where possible and where, of course, our legal department is also allowing to share specific data sets. Yeah.
Okay, thank you. On this topic, a question. How do you design a machine learning, deep learning model given how heterogeneous are the logs that a Splunk instance can receive? And a second quite funny question is, can you see Stuxnet on your data with Splunk? Can we see some, I will say, traces of Stuxnet attack on with Splunk?
So I'm personally not having data that would contain any Stuxnet, but if you would operate in a place where you would have such data, then possibly with the right detection and the right knowledge, you can see it, possibly. Depends on the data that you process in Splunk. But in general, I'd say related to that first question, how to essentially also prepare heterogeneous data. Let me quickly jump back here in my presentation to this security data journey that I talked before about. Typically, the heterogeneous data is existing here on the lowest level, for sure. This is the entry level. So really the whole, simply call it, varieties of all various log sources, log types, and so on. In a next step, and this can be easy, let's say, addressed in Splunk with a function called field extraction, which is essentially a way of regular expressions that formulate how you can extract specific pieces out of your raw log streams. And then you go into what we use, for example, in enterprise security and also in other regards, a so-called common information model. So way of a normalization layer that really says, okay, data source A and B, they are maybe from two different vendor devices. The important aspect is the IP address. Here it is called source IP, here it is called maybe just IP, and then we can consolidate this and merge this into a normalized, let's say, layer with one additional performance optimization that we typically talk about accelerated data models for specific purposes. So there's a bit of, call it, heavy lifting ongoing from really the raw heterogeneous data to a more, call it, refined or normalized data that can then be very quickly accessed and, let's say, queried by the Splunk language. And this would now then go over to say, on top of such a data set, we want to do the modeling efforts, because then we already take advantage of all the pre-processing of all the, let's say, standardization or normalization that is happening. And then actually a model can always, at least in principle, be sure that the structure is the same, that we are not, seeing any huge changes. For deep learning, it might be a bit different. However, I'm currently mostly seeing Splunk customers exploring deep learning to either improve specific other models that they have built, and they want to really benefit from a more deep learner approach. There are a few examples that we have seen here, but it's, let's say, just another way how to build specific models on top of, as I said, in principle, always a nicely refined and let's say, normalized data structure that is then useful for those type of operations. Yeah.
Okay, thank you.
I
You're
would say
welcome. Yeah.
1 to 2 more questions and then we wrap up.
Okay, so two questions and then wrap up. Okay, so I will go to quite, I will say, research questions. There were a lot of them, and there were very general questions, but maybe if we have some time at the end. So, is explainable AI a challenge for you? And do Splunk have some research in the field of human-centric computing to help people to take decisions with fancy visualizations or user interfaces?
Okay, so the first question, explainable AI, definitely a topic. We had activities also with the World Economics Forum and a few colleagues of mine who collaborated there, let's say, not only on the technical side, but also on, call it, ethical or, let's say, other regulations related aspects. The main aspect around explainability for specific types of models, I think this goes then a bit more into the modeling details. There are ways to utilize libraries like SHAP, to name out one example, but just to have an additional layer of, here is my model and I have additional functions and let's say, functionality tied to the execution of the model to either explain the model itself better. This would be, at least in my reading, one way of explainability. The other way would be also to say, let's say you get a detection, you get an anomaly detected by whatever, let's say, modeling efforts you do. You could also say and explain how the result of this model came into place, and then also attach, let's say, context-related information for that model, which also helps, of course, for example, a security analyst to understand, okay, my model tells me I should see 20 logins occurring on the system. Now I see 500. This is a strong difference, and I can explain why it is happening. So this gives at least, I'd say, not really explainability, a bit more maybe transparency also, which is definitely also part of that, to combine this. But something that we also see upcoming, but often our customers have also very smart, let's say, data science folks around who can also find, additional ways how to do this or how to bring this in. But I'd say definitely something to look at or to keep in mind. And
Okay.
for the human-centric computing, UI visualization, so in general, in Splunk, what I showed before in the example of the DGA app, we have various ways to build data visualizations in terms of dashboards, different statistical graphics that you can easily combine together. This might be one reading to make also, of course, sense out of your data, to quickly see what's going on, and also to surface and to interface this in a visualization way for more an visual analysis of data, instead of course, doing more the groundwork on the statistics side and so on the other end. But I'd say from that perspective, this is interesting. We also had various explorations, including augmented reality, virtual reality applications. So here I would also say pointer to our Splunk pages and just search a bit. I think there are some good videos to be found, or some conference talks again that highlight some of these aspects. Yeah.
Okay, thank you. So back to you, Mark Oliver, I think.
Okay, then I take the privilege of asking you two more questions, or three. You were just talking about data is the key, and in your talk you were also talking about data quality. And my question would be, what is defining data quality? So what are the factors that make data of high quality, and related to that, which would be the metrics to assess the quality of data? And I ask the question because it's not at all obvious, because data quality could be influenced by the skills of the team, it could be influenced by the data source, by the reliability, and so on. So it's a really vast spectrum, and therefore I'm very interested in hearing what you would say would be common criteria, how you would assess data quality or define it.
Very, very good question, and actually a hard one because it's really covering so much complexity. Let me frame it this way. So as soon as data arrives in the Splunk platform, and admittedly, beforehand, there could be so many things that go wrong, right? From erroneous sensor readings that just the device is not capturing the data in the right way. Could be one source of error, or any, let's say, maintainer, or where the origin of the data source is, that something is going wrong on that side. I would say out of control. Let's state it for this entry point, right? There might be controls that you want to build additionally on top of that to have a second control, to have something to compare against. But this might be a bit too complex to start with. What we mostly see is, as soon data is getting indexed in Splunk, we can do obvious things like continuous monitoring of the data stream. So this is what many customers do to ensure I'm always getting a right data feed. There's not like a gap in because some network issues were, or some service went, out of order, and therefore I'm seeing a gap in my data. So to prevent data loss, let's say, by active monitoring, if the data sources are more or less all active, right? This would be a first, just on the, is some data streaming in aspect. Then it goes into the detail of structuring, or more structural changes. So what we can also monitor, what we have seen at customers, if really the structure of a specific data source is changing severely. So there's, for example, the punct notation that is always carried on. So you could very simply say, okay, do I see strong changes in the punct notation just to see structural changes? This is one aspect of ensuring, let's say, data quality more on a structural level. Then it goes more into, I'd say, semantics, or the human aspect that you touched before. Let's assume we define a field extraction. Let's take again the IP address or any other, interesting, relevant part of our data that we want to use for some analysis. Then, of course, again, you could say, well, does this field carry null values? Very simply put, because the regex is not matching. Here we go. So this would be then more on this side. Mismatching types. So you could say, okay, I always want to ensure it is an IP address and it has whatever the 3 dots in between and digits with a specific defined thing. So this could also be an additional, let's say, more stricter control how you would extract the IP address, and if a well-designed regex would match or not match, you would also know this field is supposed to have an IP address, but garbage is contained. So that's the next level, and then it essentially goes, if you would, let's say, fulfill all these things up to that level, at least then I'd say you have a good foundation for some modeling efforts that would be then conducted. But I know very often people are just missing out on all the steps before and just jump straight away with a data set into the modeling exercise. In many cases, then later they find out, okay, I see null values here, I see a missing value here, I see inconsistencies across whatever data stream A, B, and C, and then they actually need to circle back and do all the groundwork again. So this is what I was at least, let's say, observing or seeing in concrete projects. But I hope this gives a few aspects around ensuring data quality, at least to the, let's say, to the possible known techniques that are also technically, let's say, feasible to implement. Yeah.
Definitely.
But hope this gives a perspective. Yeah.
Definitely, and also a really great answer, because especially this data quality issue, as I also mentioned it, is something that is non-obvious and obvious in the sense that it's something you would intuitively not think that you have to take care of it, but at the same time, when you have processing later, it's clear that when the lowest bricks or the input is not reliable or trustable or integer and so on, all consequent steps are obviously affected. So yeah, thanks a lot. Thanks a lot for the answer. One more content-based question, which is, what would you, and it's again an open question, so I don't expect the answer for it. It's more like, what would you say is the role of AI? And how will it evolve? And I'm not only thinking about defense, we're talking about defense mechanisms, but also about attack mechanisms. Do you think in the upcoming years we'll see more AI-based attacks? How could the use of AI evolve for the defense? Do you have some thoughts on that?
Yeah. I think I reflected on that a bit, and there's the also research field of adversarial attacks in cybersecurity related detections, but also, as you say, on the counter side, obviously everyone has access to AI-based techniques, tools these days. So I'd say it's the same cat-mouse race that we are experiencing for decades, as long as we know IT security, I think. So for sure, there will be new attack, let's say, mechanisms being made or being made up that also harness or leverage some of the ML techniques, or the other way around, that try to, let's say, poison your machine learning model system by trying to whatever mimic in a specific way. So you could say, instead of being very loud and active as a malware, you want to hide and maybe, go more or less into noise and not be the signal that is getting detected. So I think from that perspective, it's an evolution that takes place on both sides. And I think we have no other choice in terms of, just keeping up what's going on and evolving as well. So that's at least in a generic way how I'm seeing things.
Sorry to interrupt, because I think there is a trouble with the stream.
Oh, really?
LinkedIn stream is down and YouTube seems to be blocked.
Mhm. Just restart, but it doesn't matter because we still have the recording.
Okay.
So good, yeah, but thanks for the notice. But the Facebook stream at least is still running. Very good points, and I would add that AI-based attacks are automated attacks that use fuzzing and
Sorry, Mark-Oliver, but YouTube is not functioning yet.
yeah, it doesn't matter. I mean, I don't know if it will come up. So
Okay.
as long as we have the recording, I think it will be okay now.
Okay, sorry.
Yeah, it seems to come back now, I guess. So yeah, so I would say that AI-based attacks can be automated attacks that in addition use fuzzing, and that means for people that did not care about cybersecurity yet, this is even a bigger threat than the threats that were existing, and therefore people should really be alarmed in the sense that that they have to invest in tools like Splunk and knowledge and cybersecurity in order to keep up with their business, because we also had like a lot of questions regarding awareness, education, and so on. Very good. And maybe last question, which is again like a question where I don't expect the perfect answer for, of course, is what would you say is the biggest cybersecurity challenge that we face today?
Good question. Not sure how to not really perfectly answer. You said it doesn't need to be perfect. I think what we generally see, and this is also available in some public reports, specific threats are getting more sophisticated, more complex, more, let's say, really built out by specific organizations or entities who conduct those type of activities. So I think there's way more complexity to expect what's happening. The recent supply chain type of attacks are, I think, one example of those type of relations where you are essentially in a place. The question is whatever piece of technology, piece of software you can really trust end to end, because you have more or less complete control about everything. I mean, this is not hard to achieve or hard to have anyways in a very still connected, globalized, differentiated world as we are facing these days. So I think at least the challenge that I'm seeing here is to better capturing these type of dependencies and how they are made up, and how possibly if something is getting noticed, it affects other things. In the beginning of my introduction, I did lots of, let's say, activities in the research of graphs and networks, and I think this is a methodology that might also be very applicable and very interesting to see in future, also getting more integrated into cybersecurity related analysis or detection techniques to say not only whatever signal 1, signal 2, signal 3 is showing me something, but I can really bring this together in a connected way and then derive further insights from such a graph representation of some dependencies. So I think, at least from what I'm observing or feeling, this could be one of the greater challenges in future, and possibly one attempt or approach to tackle that, or to get this framed.
Very good, very good. And also, of course, a lot of research going into that direction. We are also going in that direction, obviously.
Yeah.
Very good. Yeah, very good points. So, thanks a lot. It was a really great talk, and lots of insights, and it was more than meeting my expectations, especially in the sense also that you managed to do the transition from technical insights to a more general overview. So I think everybody who was joining could definitely, and watch the recording afterwards, can definitely take something from it. So a really big thank you to you, Philipp. It was a great pleasure having you. Thank you. As a representative for the digital audience, and also big thank you to you, Alex. You managed the flood of questions as usual perfectly. So thanks a lot for that. The next edition will be on the 31st of August, which will be the last Wednesday in August at 2 o'clock, almost certainly. I didn't confirm with Christian yet who will be the speaker, but almost certainly it will be the case. We'll run live from Berlin because we'll be in Berlin, but Christian will be connected at distance. So our next speaker will be Christian Hasselmann. He's the director of the Seiden Labs in the Netherlands. And regarding the title of his talk, I don't have the title yet. So yeah, if you did not subscribe yet to the website, do so. So Talk Cybersecurity IFR, then you get the email with the updates on the next upcoming talks. Also subscribe to the YouTube. And as always, we're looking forward to seeing you in the next edition, to hearing your questions. And yeah, and go to schoolfutureIT.org to look at if you're interested in the program and maybe participate in some of the sessions. That said, I will show you now the picture of Christian with talk titled Still to be Announced. We'll hear again the abstract of Philipp's talk so that you have another resume of what he was talking about. And then you see the upcoming dates. See you on the 31st of August. If you still go on the summer holidays, enjoy it. And yeah, until end of August, thanks to all people watching, and a special thanks again to Philipp and also to Alex and everybody else who participated. See you. Bye-bye.
Bye-bye. Thank you.
Thank you. Thanks for the invitation.
Knowledges that are used to solve real-world use cases in cybersecurity. We share insights into machine learning cases and lessons learned.
Cher Cybersecurity, pôle d'excellence région Bretagne. Au revoir et à la prochaine.